Hold on, we need a second. Okay. Yes, what is your question?
Um,
The number 11, let me see what it is. Ah, okay, the one when limit. For example, x approaches -5 and 1 over 5 plus 1 over x divided by 5 plus x, somehow similar to that, right?
yeah.
Okay, let me just write it down. Limit when x approaches 5 -5. 1 over 5 minus 1 plus 5 plus 1 over x, 1 divided by x, divided by 5 plus x. Okay. First, we see that when x approaches -5, the denominator will be approaching 0, right?
Yes.
At this point, it is not defined. Furthermore, the numerator becomes 1 over 5 plus -1 over 5, which is 0, and we don't know what is somehow 0 divided by 0. We don't know it, right?
Yes.
So what we need to do is to try to find a way to eliminate it and make it simpler. We see that, let me see. We see that the numerator here, we can somehow add them up, sum them up, make a single fraction.
Okay.
In order to do that, we need to find the least common denominator, right, of these
Yes.
two fractions. And what is the least common denominator of these two?
5x.
5x, perfect. Very good. Let me just write it down. Okay, we see that 5x is the common denominator. So this guy, we simply multiply with x and divide it by x to be the same, right?
Okay.
This guy will multiply with 5 and divide it by 5. Nothing has changed. Yeah.
Okay.
So now they have the same denominator. Therefore, we can sum them up. It means that we can add the numerator of this, which is x, plus this is 1 times x plus 1 times 5, right? And the denominator of the denominator is 5x here. And the whole is defined by 5 plus x. Now, this guy becomes x plus 5 divided by 5x, the numerator.
Yes.
Then divide it by 5 plus x, which means we need to multiply by its reciprocal,
Okay.
which is 1 over 5 plus x, right?
Yeah.
Now, this guy cancel with this guy, okay?
Okay.
Which becomes limit of 1/5x, okay? And then this function is continuous at -5, right? So
Okay.
this root rational function becomes 1/5 times -5 here, which is -1/25, right?
Okay. Okay.
Is it clear?
Yeah, that makes sense. Um, oh, can you do number 16?
The what?
Number 16?
Oh, number
Or
15.
no, 16.
60.
Yes.
Okay. Number 16. Limit when x approaches -6 of 7x plus 46. Let me write it down. Divided by x plus 6. Okay. Now, first, before doing this, let us consider the denominator, right? It is an absolute value function. Therefore,
Yeah.
it is a branch function. Here, we see the input is x plus 6. It means that it should become x plus 6 for x plus 6 positive. And it would be negative of this for x plus 6 negative,
Okay.
right? Or we can write it absolute value of x plus 6 will be x plus 6 for x larger or equal to, what is it?
Would it be 6?
Perfect, -6.
Or,
And here it is negative of x plus 6 for x smaller than -6. Okay. Now, in order to compute the limit when x approaches -6, we need to compute the left-hand limit of
okay.
this, right? Or the limit when x approaches -6 from the left of this guy. Right?
Yeah.
And this guy, if it approach from -6 from the left, it means x is smaller than -6, right?
Yeah.
So we need to use the second branch here, which means it is the limit when x approaches -6 of 7x plus 42 divided by the denominator becomes -x plus 6.
Oh, okay.
Yes, it's very important here. Now, we can do what should we do with the numerator here?
Wait, like factor it out?
We see
So
that,
factor?
yeah, we can factor. If we factor 7 out, what do we have?
Just x plus 6.
Perfect. X plus 6. So now this guy cancel with this guy, right?
Yeah.
Then it will be limit when x approaches -6 from the left of 7 divided by -1, it will be -7, right?
Yeah.
So limit when x of a constant would be that constant.
Okay.
Then another step is we need to compute the right-hand limit of this,
Okay.
which is the limit when x approaches -6 from the right-hand side. And we just rewrite the function. And we know that it is approaching -6 from the right. We should use the second range here.
Okay.
Therefore, it becomes the limit when x approaches -6 from the right. And now we just factor as we did before. And the denominator is x plus 6, right?
Yeah.
Now, this cancel with this. So it becomes the limit when x approaches -6 from the right of 7, which is
7.
perfect. Now, the left-hand limit is -7. The right-hand limit is 7. They are different.
Yeah.
It means the limit of this function when x approaches -6 does not exist.
Okay.
Very good. Is it clear?
Yes.
Mm-hmm.
Okay, my last question was for is number 18 part 4?
Number what?
18.
18, okay. Number 18, the sine function, right?
Yeah, but only part 4.
How can we plot? Do you mean that?
No, I meant part 4.
I cannot hear you clearly, I'm sorry. Can you type it on the chat box? Oh, part 4. Okay, first. You mean the limit when x approaches 0 of the absolute value of sine of x?
Yes.
Ah, okay. So in order to do this, okay, let us write it out first. The number 18. The sine function is defined as -1 if x is negative, 0 if it is 0, and 1 if x is positive. And the graph of this will be like this. So for any value which is smaller than 0, then it should be -1. For any value which is larger than 0, then it will be 1. And at 0, it will be 0. The red is the graph of this, right?
Yeah.
So from the graph, what is the left-hand limit of this
Negative.
function when x approaches 0?
-1.
Perfect, -1. And the right-hand limit of this guy when x approaches 0 from the right?
1.
1. So we see that the left-hand limit is different from the right-hand limit. Therefore, the limit of this function when x approaches 0 does not exist. Do you agree?
Yes.
Perfect. However, this part is interesting. The part 4, we need to compute the limit of absolute value of sine of x. Interesting. When x approaches 0, right?
Yes.
We have to do the same thing. The left-hand limit of this guy, which is the limit when x approaches negative, 0, negative. The absolute value of this, right?
Yes.
Don't be confused. What you need to remember is that the absolute value will return the negative of the input. In this case is sine of x when we remove the absolute sign.
Okay.
Is it clear? Or you can imagine this way. Do you remember that absolute value of x will be x if x positive, right?
Yeah.
Or negative of x if x is negative. In this case, the sine function play a role of x, right?
Okay.
It means that this guy is negative of this, and we know that when x approaches 0 from the left, it will be -1. Negative of negative give us 1, right?
Yeah.
Or let us write it this way. Okay?
Okay.
The similar story. The right hand limit of this guy is limit when x approaches 0 from the right. And we know that it is approaching this from the right. The sine function will be 1, right?
Yes.
Which means it is 1. So the left hand limit is 1, the right hand limit is 1. Therefore, the limit of absolute value of this does exist when x approaches 0 and it is 1.
One. Okay.
A little tricky, right?
Yes. Okay. Well, that was it. Those are my questions I had.
Yeah, that's it, right?
Yes.
Okay, do you want to follow me on this? I'm trying to continue explaining some example in section 2.5.
Yeah, sure.